Hi, Mr. Mac, and I've got some equipment here set up to demonstrate the photoelectric effect. We can demonstrate it simply, but the equipment here you can't use at home. So I have here a step-up transformer. It goes from 6 volts DC up to a massive 50,000 kilovolts. Enough to generate a spark between these two electrodes, which we'll see in a minute. So it's connected to a smooth DC supply that runs an alternating current, a bit like an electric bell, that opens and closes the circuit to make sure that it's alternating, and that induces then a step-up transformer to get to 50,000 volts. In front of here I've got the electroscope. Electroscope is a simple device that has a needle that can show how much charge is there. If I put my finger on it, it earths. On the top of it you'll see some zinc, 3 zinc plates that I've cleaned with steel wool to get rid of the zinc oxide. I'm going to charge the electroscope. I'm going to charge it by induction so that it keeps its charge. To do that, perspex rod and a woolen cloth. I'll just simply rub off some electrons from the perspex rod and charge it up, put my finger there and then take it away. I'll try that again. It went backwards for some reason. So let's try again. Okay, there are tricks to this that may or may not work. Right. One more time, we'll see how we go. Okay, you can see a small increase in the needle. I'll just bring it up so you can see. We're going to see that it is charged. And I'm going to put it back here so that the zinc at the top is going to be exposed to the spark. Now before I do, I'm going to turn on the UV lamp, because if ultraviolet light causes electrons to come off the metal, then this is ultraviolet light. Just buy one of these nice and cheap at a toy store and we watch what happens. So I'm shining it there, still shining it on top of the zinc, and nothing's happening. That's going to be critical to work out the frequency that does work. I'm now going to dim the light so you can see the spark in the gap and see what happens. Now the spark will produce not just bright light that we can see, visible light, but also invisible high energy electromagnetic waves such as UV and X-rays. So we're going to see what happens now. There you can see the spark, and as the spark is emitting electromagnetic waves, I need to be careful that I'm not too close because the X-rays are dangerous. Alright, I'll turn that off now. So X-rays coming from here, dangerous, so we have a risk assessment to keep at least 2 meters away, and it also produces UV rays. Of the two, more dangerous, more energetic are X-rays. But you should know that UV rays can be damaging to your skin and to living organisms. Let's have a look at the electroscope, see what happened. So if you look at that, you can see quite clearly the charge is a bit bouncy. The charge has actually been dissipated. And part of the reason for that is the UV rays have gone onto the zinc and electrons have come off, and that is the photoelectric effect.